Hi, we continue with chapter 6 and we are now looking at section 6.2, which is about finding the area under a normal distribution. Many of the distributions in which statisticians are interested are actually approximately normal distributions. And one important application of a normal distribution is that the area under any part of the normal distribution or normal curve, the bell-shaped curve, is equal to the probability of the random variable falling within the region. Okay, so the area or under the curve gives us actually the probability of a certain random variable whose distribution we are looking at. So it gives us the probability of that random variable falling within that region. Now, the area under a curve can be found using the method of integration, which is actually a calculus technique and which is beyond the scope of this book. And so we are not going to, of course, do it by that method. So what should we do? Now, the problem is that there are so many, infinitely many almost in this mu and sigma values. So there are infinitely many normal curves. Now, we cannot be like finding the area for each different kind of curve separately, like by completely from the beginning, from the start, because it's a long process. So what we do is we can standardize these normal curves and by using the z-score. So and the distribution that we get, we call it the standard normal distribution. Now, once we have the z-score, we then find out what percent of area lies. Once we have a z-score, so what we can do is we can find how much area is left behind, means it's on the left of the z-score, how much area is to the right of z-score, or how much area is between two z-scores, or how much area is in the tails of the normal distribution. And to do that, we use a special table which shows areas under the curve, probabilities, and percentiles. So the area that we look for could be the area under the curve, or could be the probabilities of the random variable falling in that region, or it could give us the percentiles of for different scores or different values. So this table is called the normal distribution table or normal distribution chart. Actually, standard normal distribution. Okay? So we are using the standard normal distribution chart to evaluate whatever is required for a general distribution. Now, these tables are provided in the end of your book in table A and B. So there are two tables. I will show you. We have them here in these notes and in appendix A. They are also printed on your formula sheet. So when you are doing homework problems, you can have your formula sheet open. I believe they give those in the when you are doing the online homework. They give them. They are accessible through the homework, online homework. So now, and down below and on the next page, you will see the formulas are here. So what we do, since we know our z values, we have to read find out the z, or read out the z values on the table, and then find out the area that is associated with that z value. So I'll show you here. So these are the tables A and B. Now notice here the first column in each is giving us a z score, but here is the z. Z, and then these are the z scores, so these are the negative ones, and on the other table we have the positive z scores, because remember in the standard normal deviation, we can be, if we are to the right of the mean, the z score is positive. If you are left of the mean, then your z score is a negative number. So how do we read these values? Well, the z score, as I mentioned above, it is constituted by the first column and the first row. So the first column gives us the z score only up to 1 decimal place, and then we can add the second decimal by adding the row, the number in the column. So for example, because if you have 3.2 and you how do you say it, adjoin it, not add actually, but if we put the 0.05 with it, so it will give me 3.25. Okay? And if it's a negative one, we do it like this. So it's a negative. If it's a positive, we get a positive. So that's how we will read these. So for example, if I want to see what is the area related to the z score, so we'll pick the number on, first thing we do is pick the z score on our given z score and find it out on the first column. And let's say our z score was negative 2.4. So I will look at, find negative 2.4, which is I see is over here. So now if there is a number with 4, so because there is nothing here, so we can say 0. So it means now we have to look for the column which says 0.00. So you can see the second column is 0.09. So we cannot take that. So last column here is giving us 0.00. So it means we have to come to this last column. So what we do, we go through this line, we read through this, we don't cross it. I'm just making the two. So basically, we go all the way to the end. And then we come from the top. So we are in this column. So if I circle the whole column, then where are we? Where the column and the row are intersecting, which is this value, 0.0082. So that is the area to the left of the z value. So this is shown in this figure here. Because z is a negative number, the bigger the z is, the value is in negative, the less or smaller this area value will be. So if you go closer to the mean, like if z is somewhere here, between 0 and 1 standard deviation. So for example, if z is negative 0.7 or maybe negative 0.3. So, or 35. So negative 0.35. So what we do, we go to negative 0.3, which is down here. Okay, so we keep going to the right, and then we try to see where is 0.05. 0.05 is this column, which is the 1, 2, 3, 4, fifth column. So we come down here. So we find, we will come down here. So it was the fifth column, so 1, 2, 3, 4, 5. So the value is 0.3632, which makes sense. Why? Because remember, when you divide it into half, so this middle line, which is represented by the z-score 0, what will be the area here? This will be 0.5, and the area here will be also be 0.5. So if our z-score is over here, the area value must be less than 1. 0 is less than 0.5. Okay, and if we are on the right side, if the z is on the right side of the mean, then the area value must come out to be more than 1. More than 0.5. It cannot be more than 1 because maximum area has to be 1. So it has to be greater than 0.5 if the z-score is on the right, and less than 0.5 if the z-score is on the left. Okay, so now let's look at what we get, area we get for our example 1. So if you recall, we had calculated the z-score for the ACT score of 23, and it came out to be 1.33. So we will go to our table and see what area we get. So since it's a positive number, I have to look at the second table. So this is something you should know. When you have a negative value, z has a negative value, then you have to look at the table with the negative z value. So you don't like try to look first in the positive and you cannot find it and then go. You should know from beforehand. You should know. Okay, so 1.33. So where is 1.3? See, the 1.3 is the 9, and then 1.33. So 0.03, because 1.3 and then next digit has to be 3. So we come down this column. So this is the value we get, 0.9082. So this is what we do. We can write it like this. So we say the z value, so when you calculate the z value, which is like, I think we did it like this, 23 minus 21 over 1.5, and it gave us 1.33. Then you don't say equal to. Okay, you don't say this. This is wrong. You don't say that. What you should do instead, so you have the score calculated. You can put an arrow and say this gives us 0.9082. So now you can, so now answering the question or writing the answer in the form of the question, we can say that the score of 23 is in the 90.82 percentile. So you can write like this, or you can write the whole word 90.82 percentile. So this is how we find the percentiles. So remember, now for percentile, you just look up the number and we need the area to the left, which is what the curve is giving, the table is giving us. Okay, so let's look at some examples now. So the cases that we can encounter, many of the, as we said in the beginning, many of the distributions in which statisticians are interested are approximately normal distributions, and one important application of a normal distribution is that the area under any part of the normal curve is represent, or it is equal to the probability of the random variable falling within that range, so within that region. Now note here that if you are asked to find any of the following, the procedure is exactly the same. So you could be asked to find area under the curve, or probability, or percentile. Now within each of these above scenarios, we can encounter one of the four cases. We could be asked to find the area to the left, which is how the table reads, area to the right, area in between two z values, or area in the tails. Yeah, so note here that I'm saying area, but as we have mentioned before, it could be probability, it could be percentiles. So it could be that find the probability that a random variable is less than some z value. Then it means we are looking for area to the left. If we have that find the area or the probability that random variable is greater than some value, then we have to look for area on the right, and so on. So you have to be careful about the words being used in the problem. So what words you have to be, you should know the meaning of. For example, at least, what does at least mean? At least means greater than, or greater than the area to right, greater than some number. Okay, at least means greater than the value. So which means we have to look for area to find the area to the right of that value. If it says at most certain values, then it means it means less than that value. So it means we have to look for area to the left of that value, of the z value. Now, if it says top C%, some percentage, C%, so it means we have to look for area to the right, like we did in our example one of from the beginning of this chapter. Bottom C% will mean area to the left. Now sometimes you will see that the statement says find the probability that the mean, the value differs from the mean by more than C%, some percentage. So it means the area in the tails. Okay, and then if sometimes it would say find the probability that the value differs from the mean by less than 3%, then it means area between two values. So in this case, we do not talk about probability that X is a specific value. So if you recall in the discrete distribution in chapter section 5.1, you calculated, like for example, probability that X is equal to 4, right? But here we cannot. It will be the same as probability that X. So this way would actually say 0. Okay, the probability at X is like is basically saying what is the area under like some value. So under a point. So what is the area over here? Nothing, right? Area is 0. So we do not find this thing. Okay? Also, in this case, the probability that X is less than an X little x value, which is the same thing as probability that Z is less than. So it will be the same as probability that X is less than or equal to the little x. And this is happening, and this we can do because this distribution is the normal distribution is a continuous distribution. Okay, so it says, okay, it is continuous probability. Instead, we refer to the probability that X is within a range of values, okay? And thus choosing to include the endpoint of our range does not change the value of the probability or the area. So we can say that probability X less than or equal to X is equal to, sorry, it got split up. What it is saying is that what I just wrote up there, that probability that X is less than or equal to little x is the same as probability X is less than little x. That's what it is saying here. So now the 4 scenarios that we talked about here, they are represented here by these 4 curves. Okay, so if the question is asking you to find the probability that X is less than, because remember we will this is what the question might ask, but eventually we have to change it to z-scores, so it becomes probability that is Z is less than equal, the big Z is less than or equal to some little z. If you want, you can call it Z sub 0 or just Z, or probability that Z big Z is less than the little z. So which means we will be just looking at Z in the table. Okay, so we will look for that Z value, and then by matching the column and the row, we get our area. If the question asks us to find the area to the right of certain value, then we will look up negative Z. We will look up negative Z, and I will tell you just in a minute why. And so that will give us the area to the right. Just notice here that this, because of symmetry, for example, in these 2 pictures, the first and the second, this area is the same as that area. And if the Z is on the left here, in the first case, then it must be a negative value. So this Z naught will be actually the same as this D naught, but with the negative sign. So if the question asks you to find the area to the right, you look up the negative of whatever Z value you have. Then if you have to find the area between two x values, so if you have x1, the probability that x1 is less than or equal to big X is less than or equal to x2, so it will become the same as this probability that the z1 is less than or equal to big Z, which is less than or equal to z2. So, so it will give you the area between them. So how do you find it? Formula will be that you will go look up the z2. Okay, so when you look up z2, you get an area, and then look up z1, you get an area, and then you will subtract the smaller from the larger. So which one will be the larger? Because remember, when we are looking at the number c, wherever it is, the area is the one that we find on the left of that z value. So if z1 is here and z2 is over here, then whose area is more or larger? The area related to the z2 number. So you will this area minus that area, that will give you the required area. And then sometimes the question will say find the area for a random variable which is less than a value or greater than a value. Okay, so we could have b that our big X is less than or equal to some little x, or, so if you recall, or is a union from chapter 4. So if we are looking, so we will have to unite them, bring them together. Okay, so probability x is less than or equal to 1, or x, big X is greater than or equal to x2. So this will be the same as probability that x is less than or equal to x1 plus probability that x is greater than or equal to x2. So now to find this, we use this is the case of this first picture, and the plus probability that x is greater than x2 is the case of the second picture. So for this one, we look up x1, and for that we look up negative of x2, and then we add the two values. The area values, okay? We don't add the z values, we add the area values. Okay, let's do some examples so that it becomes more clear to you guys. Okay, what happened here? Okay, so first one, it is asking us to find the area under the standard normal curve to the left of the z value 1.37. So you see, draw your curve. If you draw your curve, where will be 1.37? It will be somewhere over here, 1.37. So we are looking for this area. So you should know from before you look up the table that the value must be bigger than 0.5. So you say this is the area equals. Okay, now we'll go and look up table. So positive values. So 1.3 which is here, same line as we were looking before, but now we have to go to table. So this is the, we are coming down here and going, so this is our value. What is that value? So this is the value, 0.9147. So now we say, again remember, as I said, you're not going to say equal to. So you will say area equal to, yeah, you can say area equal to 0.9147. Okay, or if you want to convert it to percentage, it will be 91.47%. But so and which makes sense because area, it's bigger than 0.5. And also remember, this area, this value should never be bigger than 1. So it will not be negative because area cannot be negative, and area, total area under the curve is 1. So we cannot have a number bigger than 1. So next one is saying to the left of z is equal to negative 2.03. So what does that mean? It means we are going to be somewhere over here, negative 2.03. I think I should draw these curves on this side so that they are more clear. So negative 2.03. And now we look up, because it says to the left of this number, so we look up our number. So now we will be in table, first table. I would recommend to you guys as well, don't write on the table, because if you put some marks, then it becomes harder to see the actual value. If you are using a pencil, that's fine. You can erase it later on, but with a pen, you mess up your table. Okay, let me clean this table. And okay, so now negative 2.03. So negative 2.0, where is that? Can you look at it? Negative 2.0. Oh, there it is. This is negative 2.0. And then we have to go to 3. Now, you should note that in the positive table, the first column is 0, second is 0.01. So it is increasing up to, last one is 0.09. But in the negative, it is the opposite. It decreases. So it starts with 0.09 and goes down to 0.01. 0.00 actually. Yeah, because this is also starting with 0.00 and this is ending at 0.00. So 0.03 is this column. So we go down this column and we are coming from left. So a ruler will help, of course. So we see that the value is 0.0212. Does that make sense? Okay. Because we were looking at what? This, the value over here. So it does make sense, right? So the area in this case is 0.0212. Okay. Now it is saying area to the right of C is equal to 1.37. Okay. This is note here. We have C is equal to 1.37 and the A part also we have 1.37, but There it said less than or to the left of C. Now we are going to look at right of C. So the area will not be the same. But in order to find the area to the right of this, what do? We look up Z is equal to negative 1.37. So area will be equal to, so look up the negative 1.37. So negative 1.3 is this. And the seventh column is the third column here. So we are getting 0.0853. Okay, so we write that down. Area is equal to 0.0853. I hope this makes sense. Okay, let's see if you guys can try the next one. So I'll give you a few minutes to try, and let's see if you can do this. So this is saying area to the right of C is equal to negative 0.90. So just remember, to find the area to the right, we look up the opposite number. So what will we do? I hope you guys got it. Look up Z is equal to 0.90. Okay, so which gives us area equals, so 0.90 area equals 0.8159. Then you can say, does that make sense? So if I graph it, my 1.37 would be somewhere on the right here. 1.37, oh yeah, it makes sense because we have a lot of area. Whereas if I had drawn the picture and the graph for this one, previous one, which said to the right of C. So this is 1.37. To the right of this is a very small area, which makes sense here. The next one is saying area between these two Z values. So we will look up for Z1, sorry. So Z1 is equal to negative 1.68. So we look up the area. So we say, okay, rewrite this, negative 1.68. So you put an arrow. So the area for this one is equal to, or you don't need to write area, you just arrow and write the number. It is clear that you are looking at the value of the table. So our Z1 is negative 1.68. So negative 1.6, which we will see on the first column, negative 1.6 right here, and then 8. So 8 is the second column. So right here. .0838. So we take this value and we write it here. So what was it? 0.0868. No, 0.0838. Okay, I will fix that when we go back. And then the other value we have to look is 2.0. 2.0, so we have to go to the positive table. 2.0 right here. So 2.00, which is the first column. So we have the number 0.9772. Okay, so now remember we were looking for area between. So one value is 2.0 and the other value on this side was negative 1.68. We had to find the area in between. So what we do, we looked up the both areas. Now the 2.0 value had a bigger area, so we will subtract the other one from this. So we do our area will be equal to 0.9772 minus 0.0838. Now take a calculator and find out the area. I believe it is 0.9307. Does that make sense? Yeah, 9307. Okay, now remember this should never be negative. Okay, I think we are on the last problem here. So now it says total area to the left of Z1 and to the right of Z2. So a picture looks like this. So negative 2.5 somewhere here. So we are looking for this area and to the right. So 3 is somewhere here. So we are looking the sum of these two areas. So what we do, as before, for Z1, which is negative 2.50, we look up what? Remember, we are going to look up the Z1. So when you look up Z1, let me just tell you, you get the value. Just okay, negative 2.5. Okay, negative 2.5 is giving me 0.0048. And C2 because these are entails, remember, so because we have to look for area to the right of C2, so it means we should be looking at the negative of C2. So the negative of 3, that's what I had there. This value was 3.00. So I look up 3, negative 3. So that gives me, where did it go? 0.001. So we are looking actually at negative 3.00, which gives me 0.010. So our area will be equal to the sum of these two, 0.0048 plus 0.0010, which gives you 0.0058. So that will be the answer. You can box your answers. So this is how we use the tables to find the areas. So this was section 6.2.